Here. Cool. So, all right, we are recording now. It's Tuesday, May 12th, 10:30. Let's start off by going over some of the announcements. Well, sorry, I paused. My screen should have moved to an announcement screen. I don't know what's going on. Again, sorry about this. This is kind of weird for me right now with the whole update. It doesn't look like, can y'all see the announcements page, green background? Because my screen is frozen on the,
No, we can't.
dang it, okay. All right, so it looks like I'm going to be experiencing some difficulty here. So let me see if I can just share my actual computer screen. And thank you all for answering that. I don't know what's going on here. Cool. So now can you see, because this is my actual laptop, can you see the green screen that says announcements? Hopefully. Are we all good with that? Seeing the thing that says remote learning agenda and RLQs. I don't know why it's not working with my iPad, but hello, hello?
Yeah, we can see the green.
Cool. Thank you, Brooke. All right, awesome. So announcements, the same thing I basically say at the start of every class, remote learning agenda, RLQs, keep checking them out, keep using them. The RLQs is just that remote learning questionnaire to let me know if you have questions. A lot of you have realized you can ask me the questions here in person or over email. I think email is the preferred method, so feel free to continue doing that. Here's a big one, number 2, ed puzzles and assignments, updated due dates, y'all. Friday the 22nd is kind of our flexible finish line. You might have heard that phrasing in some of your other classes, but I'm trying to basically get all of our assignments in by next Friday. Not this Friday, but the Friday following. So ed puzzles and assignments have been adjusted accordingly to meet that deadline. And that's going to open up the last 2 weeks, the late 20s of May and the first week of June, which was originally scheduled for finals. That'll open that up for just kind of really drilling in and trying to get that grade that you want in this class. So long story short, get all those ed puzzles and assignments in by the 22nd. A vast majority of you, both those of you that are here in this session right now and those of you who are not, if you're watching this on YouTube, have done a really good job with that. My Algebra 2 trig classes, you guys are crushing these assignment completion, so good job on that. Continuous office hours for Zoom sessions, Fridays at 11 a.m. Feel free to stop in if you have any questions or just want to say hi during that time. All right. So the red types, the red text is basically the main new information other than the 5/22 deadline for homework. So I'm going to post something on the Google Classroom. It's going to be called the FAQs and info sheet. I'm actually going to roll to that right now, show you what that looks like. Sorry, it's just kind of a weird adjustment since I have to do all this on my laptop. I had it all queued up on my iPad, but then it decided it didn't want to do that anymore. So bear with me just 1 second as I pull this up in my drive. All right. Again, the woes of updating an app before you plan on using it. Okay, so most of these FAQs you already know since you're here. When is the Zoom session? You already know what that is. Let me zoom in a little bit on this so make it easier for y'all to see. How do you submit work? Basically, every single one of you in here has already answered that. I mean, knows the answer to that. Okay, this is basically the last few questions are the ones I really want to focus on. How are grades going to look? If you haven't heard it in any of your previous classes, here's basically the rundown. A, B, C, credit, and no credit. Now, it's not super important to y'all because I don't believe that there are anyone in my Algebra 2 trig classes that actually are in the kind of phrase between credit and no credit, meaning none of y'all are failing, so you don't have to stress that. But if you were to get a D in this class, and I don't believe anyone in here has that, it would be counted as credit, whereas failing would receive no credit. That's more for maybe your other classes because, again, y'all are doing great in my class. You're putting in a lot of hard work, and I appreciate that. Here's a big one. Will there be a final? No final in this class. We've kind of danced around the idea of a final over the last 2 months, and I've said, all right, I'm not going to do a traditional final. I'll do a project. And now I've even kind of adjusted that whole train of thought. So here's a big kind of important piece of information as this class moves forward. There is not a mandatory final. There is not a mandatory project. The key word in those last two sentences was mandatory. I will provide an optional project for those who want the opportunity to boost their grades up, okay? If I've reached out to you individually, take that information as what it is. We've already spoken, but if you want to boost your grade up, if you have a C or a B, and you want the opportunity to boost it up to maybe a higher letter grade or a plus or minus in that range, please let me know. Now, this isn't saying that if you have a C, doing the project will boost you up to a B. That's kind of a big jump at this point in the year, but it does give you an option to potentially get more work if you're right on that cusp or that verge from B to A or C to B. When is all work due? Keep in mind, we just said May 22nd. If you weren't here for that, all work other than the optional project is due by Friday, May 22nd, next Friday. Cool. How can I raise my grade? Do all the assignments, then do the ed puzzles, and then do the optional project. So I really want to just kind of reiterate one more time that the project is not mandatory. It is going to be assigned on the 22nd and will be due after that. It is optional, and it is literally there just to see what we know about specifically logarithms and help you boost that grade up. Does that make sense? Does anyone have any questions either on that or really on anything as it relates to this class as we move forward? Because I know it's been a big adjustment and y'all been doing really great with the different pieces of information as we move forward. Any questions on that? Cool. All right then, so that takes us to number 5. And again, a lot of this information right from the jump is just straight kind of busy work, or not busy work, but informative in the sense that it tells us how we're moving forward for the rest of this class. We really only have a few weeks left, so kind of trying to really only focus on the main important details. So number 5, let's talk about the year-end form. So I'm actually going to pop out of this again, unfortunately having to jump around here because, yeah, you already know, I don't need to say it again. But I'm going to post on the Google Classroom today this form that you see, okay, this form right here, and it's called the Remote Learning Year End. I just want you to put your name and your email into it, and there's really only one mandatory question, and it is this 4th box that says, based on your grade in Infinite Campus, choose the option below that best suits your desires. So because of this flexible finish line, because of the optional final project, again, optional is the key word there, I'm going to basically try to solicit or get your responses on how you feel with your grade and what I can do to help you moving forward. So before you fill out this response, it will be posted this afternoon. Before you fill out this form, go onto your Infinite Campus, see what's up, see where your grade's at. See if you have turned in all the assignments. If you haven't, turn it in. It'll obviously boost your grade. So if you're satisfied with your grade as is, this is your first option right up here. If you're satisfied with your grade as it is and you're not interested in receiving another project, then you can click that box, boom, and then I'll know that. If you want an opportunity to boost your score, to boost your grade up, grade might be a better word for that, let me know and I can let you have that project. You can also email me individually, but this form, as you know, allows me to collect this information very quickly and efficiently and see who wants what and what I can do to help you. Also on this form, you see a little bit lower, if you want to boost your grade, are you willing to join Zoom sessions? Obviously, if you're here right now, you are because you're already doing that. And if you have any questions, comments, or concerns as it relates to your grade, this is just a fill in the blank. You can write whatever you want down here in the last paragraph. The main thing I'm looking for here, y'all, and the only really required piece on this form is your names, your email, and this based on your grade in Infinite Campus. Are you satisfied with your grade? And do you want to boost your grade? And legitimately, if you have a C in this class and you're like, a C in Algebra 2 Trig, I count that as a success and you're satisfied with it, boom, there it is, okay? We're gonna go through May 22nd and get all that assignment in, but if you're satisfied, I won't give you the project. If you want the project, this is the option to let me know right here. Does that make sense? I know I'm throwing a lot of information and I'm kind of repeating it and saying it a lot, like reiterating it over and over again, but I just really want to make sure that we can get this. I got a great question. How do we access this form? Fantastic question. I have it queued up in the classroom right now, but you can't see it because I haven't posted. So long story short is I will post this form right after I eat lunch today, probably around 1 o'clock. Great question. So yeah, keep an eye out for this form, and I will post it a little bit later on once I'm done teaching my Algebra 1 class and having lunch. Cool. Any other questions as it relates to what we've discussed so far? Keeping in mind, we actually haven't talked anything about any math yet, just really the information as it relates to this class. Oops, goodness gracious, sorry about that. Don't want to share 100%. Okay, cool. So we all understand then new deadline for homework, where we can find information on the facts sheet, and then the year-end form, which I'll post this afternoon. Which basically, we've already mentioned it like 5 times here, but number 6, optional final project. That'll be posted next Friday if you want it. If you don't want it, that's why it's the keyword optional. And guess what? We got 3 weeks left. This week, next week, and then if you want more opportunity to boost your grade up, that 3rd week, the last week of May, and then we're done and we are rolling. All right, one last time then. Does anyone have any specific questions before I commence into finishing up some lesson 8 homework problems and then moving into lesson 9, which will be really the last lesson that we're going to use in the textbook this year. Everything we do next week will be done via Khan Academy and online. Cool, I'll pause for a second here, see if any questions roll in. All right, cool, let's do this then. So it might be kind of tough here since my screen sharing wasn't really working as how I hoped it would. Close that out. But what we're going to try to do today is we're going to continue to further our knowledge of trigonometric functions, graphing sine and cosine functions, not as a circle, but as an x and a y axis. We'll see that they're going to be wave-like, and we will do so through detaching, meaning basically like a string, taking apart the inner circle and graphing it on the x and the y axis. We'll explore the cosine function. Last Thursday, we talked only about the sine function. So without any further ado, we're going to move into, I call it the warm-up here on the left side of the screen, but I want to move into pages 129 through 132. That's in lesson 8, and we're going to do a couple homework problems, numbers 5 and 11. All right, so let me bring it back to my iPad here, see if it wants to work efficiently. All right, cool. So hopefully y'all can see my iPad screen now. Again, sorry about the inefficiency of this whole situation. It's kind of being a pain in the butt today with the new updated app. Can y'all see the little circle that I have drawn on page 129? Y'all can see what I have controlling my iPad. Sweet, I'll take that as a yes, since I didn't get anyone that said no. So that's good news. Okay, so here on page 129, this is a homework problem from lesson 8. We're looking at a situation where we have a Ferris wheel that has 40 feet in diameter. It's 40 feet in diameter, and it's rotating counterclockwise. So when the passenger car is at the bottom, it's located 2 feet above the ground. So I kind of drew this on the text that you'll have, the PDF version of this text. This image is not shown. I drew this image, and here's where I got the information. At the bottom of the Ferris wheel, it's located 2 feet above the ground. That's where I got that little piece of information. And the Ferris wheel has a 40-foot diameter. That's where I got that information, 40 feet. Everything else that I have drawn here is just a really poor drawing, but it's about the extension of my artistic skills here. Here's my little supports for my Ferris wheel, fulcrumed or centered at the center, and then the actual circle itself is the Ferris wheel. Down here is grass, which doesn't really exist where we live too much, but you get the idea. There's the ground. So we want to sketch a function that represents the height of a passenger car that starts at 3 o'clock and then for one whole turn. So we know again that this thing is turning counterclockwise. So what we want to do is sketch a graph of the function, And we want to do so, typically how we normally graph functions is on the x and the y axis. So I'm going to create over here on the right, the x and the y axis. I'm going to focus really only on the first quadrant because we can't get to negative height here. Notice that this Ferris wheel isn't dropping down beneath the surface of the earth, so negative height's irrelevant. And turns, we're not going backwards in a turn, we're only turning forwards in the context of this. So my y-axis is going to be my height, and my x-axis is going to be basically the rotation or the turn. Let me write that as rotation. And by the way, just in case we missed it, this is on page 129. It is lesson 8. It is homework problem number 5. All right, so when we start off, what is our height at? Well, when we start off, if we get in the car at a position of 3 o'clock, I got that information right here. Well, 3 o'clock is right about there on the circle. So when we start off, if that's where our starting place is, what is our height currently at? And that question really gets built off of our knowledge of the diameter. We know the whole diameter is 40 feet, but 3 o'clock is right in line with our center, meaning 3 o'clock really is only the radius here. So the radius is 20 feet if the whole diameter is 40 feet. Hopefully we can kind of understand how that logic came about. 3 o'clock is halfway up the height of the circle. Therefore, it's really just a radius above the bottom of the circle. So therefore, if we were 2 feet above the ground here at the red dot, and now we're 20 feet up above that, well, the height that we're going to be at here is going to be 2 plus 20, or 22 feet. So our starting point, when we have made 0 turn, 0 rotation, our y-intercept, so to speak, is at 22. Let me graph this in green here. Okay. Now I'm just going to focus on the quadrantal angles. We don't need to go into 30, 45, 60-degree movements, flashing back to that crazy unit circle. I'm just going to focus on the quadrants. So here's where I'm going to focus on. We started there. I'm going to go 90 degrees, 180 degrees, back to a full rotation. So at 90 degrees rotation, 180 degrees rotation, 270 degrees rotation, and then last but not least, let me get that word out of there for sake of room, 360-degree rotation. So we know at 0 degrees, we're at 22 feet up. How tall would we be once we've made a 90-degree rotation? Well, we would be now 40 feet, top of the circle, 40 feet above 2, which is 42. So at a 90-degree rotation, we'd be 42 feet up. Boom. And then we go 180 degrees. We go 90 more degrees. So now we are at this point. We've gone halfway across the circle. But keep in mind, if we are here, where the red dot is currently, we must be at the same height as that 3 o'clock start. So realistically, at 180 degrees, we are back to the same height, the same place on the y value as where we started. Then we go 90 more degrees down to that point right here. Keep in mind, y'all, we know the height of that thing. It's kind of, my green little dash here almost obscured it, but it's only 2 feet off the ground. So now, really what we're working with here is, I'm going to go down here and say 2 feet. At a 270-degree rotation, 90, 180, 270, we are only 2 feet off the ground. Boom. And sure enough, last but not least, the final 90 degrees, back to where we started, back to our starting point right there. Well, we're going to be at the same height as where we began, which was at 22 feet. Now, the point of this practice and procedure is to realize that we can basically unhinge or detach a circle and graph it in a new way. If you were present last Thursday, we kind of saw this idea through problem number 4, I believe it was, on the practice problems, not the homework problems. But we saw that we could take a circle, unhinge it, basically cut it at one point, and then graph it on the y and x-axis as we've done with most other functions that we've graphed up to this point in math. And that's basically the representation of that information. All right, that is number 5 on page 129. If you have already completed it, that kind of verifies why the answer key said it looked something like this. Sorry about that. Why it looks something like this. And if you have not done it, well, this is how the process worked from our knowledge of a circular movement on an x and a y axis. All right, I think one of the last few problems that we had to do on the homework, and one of the ones that I specifically wanted to focus on, is a review problem where we're focusing on the Pythagorean theorem. And keep in mind, y'all, the Pythagorean theorem is a squared plus b squared equals c squared, which is just a fancy way of saying small side of a right triangle plus small side or other leg of a right triangle equals hypotenuse squared. You can call these variables whatever you want. It's irrelevant. But leg squared plus leg squared equals hypotenuse squared. So what do we know right now? I'm going to kind of color coordinate this. I'm going to call this my A side. I'm going to call B squared my 8. And the reason I know that 4 and 8 are relative to A and B respectively is because C is always the hypotenuse. C is always the hypotenuse, and the hypotenuse is always across from the right angle. So thus, really, that has to be my side C. Whether A is 4 or A is 8 is truly irrelevant because we know commutative property doesn't really change that answer. So final step is we take A, square it, plus B, which we called 8, square it, and we set it equal to C squared. Sweet. I'm going to do this really fast now because I have a hunch y'all really comfortable with this. 4 squared is 16, 8 squared is 64, C squared is what we're looking for. We combine our like terms, add those up is 80. We undo a square by using its inverse and opposite operations, square rooting. Got a lot of practice with that this year. And the square root of 80 is going to be approximately 9. So I'm going to say C is really close to 9, or maybe like 8.9. And the reason why I know that is, without even using a calculator, is that I know that 81 is a perfect square. The square root of 81 is 9, so therefore 80 is super close. It's got to be really close to the square root of 81. All right, lesson 8, sorry, problem number 11 in the books. Hopefully lesson 8 homework now can be completed moderately efficiently, which is going to take us for our last few minutes to lesson 9, where we're just going to see a repetition of the Ferris wheel problem that we did up here in number 5. And we'll finish this off real quick. All right, so let me back out of that. Cool. So last thing that we're going to do for today, unless y'all have any specific questions, is going to be on page 138, problem number 1, part E. In the book, they don't have these 2 unit circles for you. I copied and pasted them because they'll make our lives much more efficient and easy when we do part E. And what we're supposed to be doing here on page 138, 1E, is basically graphing on a function table, or sorry, using a function table or on a coordinate plane, the functions sine and cosine. So the first thing I want to do is take a flashback in memory, down memory lane, and remember, oh, sines are all the y values, and cosines are all of the x values. So what I'm going to do here real quick is I'm going to highlight all of the y values on the left side. Y, you get the idea. Hopefully here, let's just make this quick. Y, all these y values. These are all the sine values at any given point on the unit circle. AKA, hey, what's the sine of 150? Well, the sine of 150 is the y value at 150, 1/2. What's the sine of 315? The sine of 315 is negative root 2 over 2. Cool. So what I'm now going to do is, just for sake of time, is I'm going to actually work towards progressing and graphing this from that information. So what I've done here on 138 is I have described what I'm going to call my y-axis. It's the numerical value, the decimal, and the x-axis is degrees, so I labeled my axes. And notice I have my degrees everywhere from 0 to 360 horizontally. And then I threw specific numerical values that make it easy for us. I got these numbers from a calculator. I took all of the ordered pair numbers, root 3 over 2, root 2 over 2, and 1/2, and basically stack them vertically in descending order as such. So now really what I'm going to do is to make this process a little bit more efficient is I'm just going to go and take a look at my values. And just for sake of time, I'm really only going to focus my time on the quadrantal angles, 90, 180, 270, and 0/360. So let's do that real fast. At 90 degrees, what is my sine, aka my y value? It's 1. Cool. So I'm going to cruise on down here, and at 90 degrees, I'm going to go up to a y value or a height of 1 and drop my point. Cool. At 180 degrees, what's my y value? 0. So at 180 degrees on my x-axis, I'm going to go to a height of 0 right on the x-axis itself, an x-intercept. At 270, what's my y value? -1. So at 270 degrees, as I progress over here, boom, there's 270. I'm now going to have a y value of -1 right on down here. And last but not least, at 360, I'm going to do kind of two things here at once. At 360, aka 0 degrees, a full revolution, a full circle back to where we started. What's our y value? 0. So at 360, I'm back at a height of 0, which is also where I started at 0. I had a height of 0. So very similar to the graph that we just created. Sorry, I'm trying to trace this without being able to see it all. Cool. We have our sinusoidal graph. It's a wave-like motion. Obviously, if I wanted to get more accurate, just for sake of real quick explanation, you could see at 60 degrees, my y was root 3 over 2. So like at a 60-degree location right here, I would be right at root 3 over 2, which my quick sketch actually did look a little something like that. At 30 degrees, it was 1/2, which again, my quick sketch did kind of verify. So basically, this curve right here is a bunch of different points that are all obtained from our knowledge of our beloved unit circle. Now, the last thing we're going to do real quick today is see the difference between sine and cosine by measuring the cosines. And I'm going to do this real fast and efficiently here by realizing that, hey, cosines are all the x values. So I'm going to go to my quadrantal, my big 4 angles, and look at all the x's. Cool. All right, zooming on out. See if I can do this efficiently. At 0 degrees, what was my x value? 1. So at 0 degrees, my x value is at 1. Start at a height of 1. At 90 degrees, what's my x value? 0. So at 90, we're down here at a height of 0. At 180, what's my x value? 180 degrees, x value is -1. So at 180, I'm dropping down to a height of -1. At 270, I'm back at 0. And at 360, I'm back to where I began, same height at 1. We see our flow there. Cool. And as if we continue to do this, sorry, that was kind of a terrible sketch, we could continually get more and more accurate as well. Now, the point of this is really just to realize that a lot of things that are measured in life are actually sine or cosine related. You look at anything that has waves, sound waves, light waves, all can be measured theoretically through this general form. Now, it obviously gets more intricate the more you get into a detail, but sine and cosine have this wave-like motion, and thus we can measure rotation and distance of something that's cyclical, that goes in circles, which a lot of things in life do. They repeat themselves, they go back to themselves through the knowledge of basic graphing, like we learned way back in pre-algebra, and now applying that knowledge with the unit circle to create wave-like motions. And sine and cosine are basically super similar to each other. This sine, you might notice, is really just cosine shifted over. Okay, so this just shifts to the sine and the cosine relative there. Now that was a very quick review, introduction to lesson 9. On Thursday, we're going to go over lesson 9 homework together, finishing up with a warm-up on numbers 2 and 3 here, and we'll really work towards understanding, at least at a low level, the graphing of sine and cosine functions on Thursday. So without any further ado, if y'all have any questions, please let me know now. If not, I do very, very much appreciate y'all being here. If you have any other questions you want to email me, as always, let me know and I'll be happy to help you out. So take it easy. Have a great rest of your day, and I appreciate y'all so much. Thank you.
Thank you.
You're welcome.
Thank you.
You're welcome. Bye, y'all.